All right, tonight we're going to be talking about amplitude, frequency, and period. Tomorrow we will be looking at phase shift. So let me just get my calculator up here so we can look at some things. Make sure you get your calculator out. Now would be a good time to grab it if it isn't out already. Okay, so what happens when we multiply a function by a value a? So what if we try y1 equals 1/2 or 0.5 sine x? If you were doing a fraction, you would want to do 1 divided by 2 in parentheses sine x versus let's put in 0.5 cosine x too. So we'll put in the sine x, cosine x, cosine x. So y1, for some reason I noticed I have a goofy, change that, there we go. Okay, so let's just put in sine x. And then let's put in 0.5 or 1 divided by 2 sine x. And we'll just go to zoom trig just to get an idea of what it looks like. So there's sine. So the 0.5, you should notice, has a different height. So when we change that, that's what's going to happen, is it's going to change its height. If I change this to 2 sine x, see how the height changes to be greater. So we call that the amplitude. So the amplitude A of a graph is the height of the curve. So when if you try y equals 5 sine x, 2 sine x, and 3 cosine x, the same thing would happen. Does the same thing happen when we put cosine in? So if I just go down and replace this with cosine in all spots, there's the original cosine curve, and there's half cosine x, or 0.5, and there's 2 cosine x. So you should see that it's definitely changing the height. So if you think about amplitudes with music, they make it louder or softer. So there's definitely a relationship there. The amplitude A of a graph is equal to, here's the definition, half the distance between the maximum value and the minimum value. And the range of these functions depends on the amplitude. So when you graph y equals 3 sine x, okay, I'll put a little heading here, amplitude. When you graph y equals 3 sine x, it's going to go as high as 3 and as low as -3. So up here is 3 and down here is -3. So the amplitude is half the difference between the max value and the min value. So this is your max value, and here is your min value. So the max is at 3, and your min is at -3. So half the difference between the max value and the min value, but we need to look at this as a total distance of 6. Okay, so don't do 3 plus -3. Okay, you need to look at it as a distance. That minimum value is -3, but this distance here is 3, and this distance here is 3. That's what we're trying to find, is kind of from that middle line of where it divides it. What is the distance from that middle line to the maximum point, or from the middle line to the minimum point? So you could take the distance between the min and the max point and divide it by 2. Or look at that. It is the number in front. So the amplitude is 3. On y equals 1/2 cos x, the amplitude's 1/2. Now, here's the thing, though, on y equals -2 cos x. Okay, we are talking about a distance. If you graph y equals -2 cos x, let's go and clear out our stuff here. So I have -2 cos x. Do we think the amplitude is -2? Well, you really don't refer to distances as negative. Ooh, I have an error there. I did something wrong. Okay, so let's see. It's my window. Okay, so I wanted to go to zoom 7. I think I went to zoom 6. There we go. Okay, so if you take a look at y equals cosine x now, and we trace that on top of it, and we go over, and let's go through that, and we can have it kind of draw it. There we go. Along, and you'll see this. So 2 cosine x. Let's hit graph. So you can see it drawing it. Doesn't it look like the original cosine graph, but it's been reflected over the x-axis. Okay, so y equals -2 cosine x actually goes like this. Now remember, the original cosine graph started at 1. Actually, it would start at 2 in this instance, whereas this one starts at -2. So it's been reflected over the x-axis, but I'm looking for the amplitude. So here's that max, which is 2, and here's the min, okay, which is at -2. This distance here, though, is 2, and this distance down to the min is also 2. So the total distance is 4 divided by 2. The amplitude is always positive, okay? So amplitude is positive. That doesn't mean that you can't have a negative out in front. It just means that your graph has been reflected over the x-axis. Okay, so then y equals 5 sine 2x would also have an amplitude of 5, even if we changed the 2x. Go put that one in your calculator and you'll still see it goes a height of 5 and as low as -5. So if I do 5 sine 2x, and I clear this one, and I hit graph, as a matter of fact, we're not going to even see the height. So this one we need to go into the window and adjust the y min to be maybe -6 and make the y max +6, because we are going to have this go from 5 to -5. That distance, though, from that middle line is 5 up or 5 down. Even though we put a number in between the cosine and the x, which is 2, that affects something different. It does not affect the amplitude. Okay, so what happens when we do put that number 2 in there between the sine and the x, or between the cos and the x? So let's take a look at some of those. Let's take a look at y equals sine. I'm going to do 1/2 x. So again, if you're going to do 1/2 x, you have to do 1 divided by 2, like that, or you could do sine 0.5x. Notice how the x stays inside the parentheses. Kids have trouble with this. So, and then we'll put in y2, we'll take a look at cosine of 1 divided by 2x, or could be written as cosine 0.5x. Okay? So let's see what happens there. Should notice maybe something here. I did 5 sine 2x. It looks like we're getting more waves. Okay? So let's put in sine of, see how the parenthesis comes up, so you need another one. 1 divided by 2 the x, and then close the parenthesis. Do not get that x outside, or it will be a different graph. Compare that to just sine x. Should have done sine x first. All right, so should be, the window should be all set up. So there's just sine 1/2. Now it's drawing the original sine curve. So the original sine curve has a little bit more wave to it. Our half one is really only drawing half a graph if you look from 0 to 360. If we take and change the window to go from 0 to 360, there's our sine half x, and here's our y equals sine x. It is graphing half of a sine curve. It's changing the amount of wave. The height is staying the same this time. The amplitude is the same. It's changing the height. And if I change this to cosine, you should see the same thing happening. It's going to do the half one first. So here's cosine 1/2 x. And here is y equals cosine x. So one complete cosine curve from 0 to 2 pi is this slow one being drawn in. The half one was the first one being drawn. That is known as the frequency. So the frequency b of a function is equal to the number of full curves between 0 and 2 pi. So if you're drawing a sine curve, and here's 2 pi, and you only see that's half a sine curve, that would be y equals sine 1/2 x. Or you could also write it as y equals sine x over 2. If you're seeing a cosine curve, and you're seeing out here is 2 pi, and you see 1, 2, there's 2 complete cosine curves, that's going to be y equals cosine 2x. Okay? So it's how much of a complete curve you're getting in from 0 to 2 pi. And remember, your sine x curve looks like this. That's one complete curve. And your cosine, y equals cosine x, looks like this. That's one complete cosine curve. Okay, so the period of a function is basically at what point do I get a full curve in. So if you look at the previous examples, if you look here at this example right here, I'm only getting half a curve in by 2 pi, so I'd get the rest of it in by 4 pi. That's the period. on the cosine one, I'm looking at like what is this spot where I finish the first curve? That's pi. So the period of a function is equal to the number of degrees or radians needed for one full curve. Okay? And the formula is period equals 2 pi divided by b. That's not supposed to be there like that. And b is the frequency. So if the frequency is 1, then the period is 2 pi divided by 1, or 2 pi. If the frequency is 2, the period is 2 pi divided by 2, or just pi. 2 pi divided by 3 is 2 pi divided by 3. And these are in radians, okay? We're going to pretend, you know, we're graphing in radians, even though the mode of the calculator is in degrees. And then if the frequency is 4, that's 2 pi divided by 4, which is pi over 2. And if the frequency is b, the period is 2 pi divided by b. Or x, or whatever you want to call it. They call it A for amplitude and B for frequency. It's the next thing that comes along. So the frequency, notice that it is the number between the function and the x. So the frequency on this problem that we did, y equals cosine 2x, is 2. The amplitude was 1. So this went a height of 1 and as low as negative 1, but there were 2 complete cosine curves. This frequency was 1/2 on the sine one that we did. Okay, so for the next ones, it says, what is the amplitude? A. What is the frequency, which is B, and the period. There is no symbol for period, just P. Okay, so the amplitude for this one would be 2, frequency 3, and the period is 2 pi divided by 3, and this is radians. Amplitude is 1 if there's nothing written there. Frequency is 2, means you're getting 2 complete curves from 0 to 2 pi, and the period is 2 pi divided by 2, or pi. The amplitude is 2, always positive on the amplitude. The frequency is 1/2, and 2 pi divided by 1/2 is the same as 2 pi times 2 over 1, which is 4 pi, which is 720 degrees. So you're getting in one complete curve. You're only getting in a half a curve here. So this frequency means you're getting in half a curve by 2 pi. So you'd get in a full curve. So this would be a half curve by 2 pi. And you'd get in a full curve by 4 pi. And then the last one, the amplitude is 5. The frequency is 1 because there's nothing in there. So the period is just 2 pi. Okay, next page. Okay, so more. Again, the equation goes amplitude sine frequency x, or y equals a sine bx, or y equals a cos bx. The period is 2 pi divided by b, which b is the frequency. Okay. And the frequency is b. Okay. It is the number of full curves from 0 to 2 pi. Which is 360 degrees. Amplitude is the height. Okay? It's half the distance from the min value to the max value. Okay? All right, so if you're given a graph and you're asked to come up with the equation, then you need to know, first of all, kind of some steps here. First of all, you need to know, is it a sine or a cosine curve? So for y equals sine x, you need to know that it goes like this. For y equals negative sine x, you need to know that it's going to just be that first graph, just a reflection over the x-axis. For y equals cos x, starts at 1, goes down, and now these are all finished by 2 pi. And then for y equals negative cos x, that's just going to go the opposite direction, a reflection. So these are all negative 1, 1. This is 2 pi, 2 pi. It's finishing 2 pi, 1, negative 1, 1, negative 1, and 2 pi. Where does the sine curve start? Well, if you look, they both start at 0. That's important. Where does the cosine curve start? It looks like it starts at 1. Okay, so this one is 1 and this is negative 1. So it either starts at 1 or negative 1, depending on if it's positive or negative. Then you want to determine if the graph you are writing an equation for is a sine or cosine curve based on where it starts. And then you want to write that amplitude, which is that height. Determine if the graph has been reflected over the x-axis, so it would be y equals negative sine x or y equals negative cos x, okay? Determine the frequency, use the period if needed, so p equals 2 pi divided by b, where b is the frequency, okay? Remember, the frequency is the amount of complete curves from 0. It's the amount of complete curves from 0 to 2 pi. Okay? All right, so here we go. Write equations for the following graphs. So it looks like it starts at 0, so that would tell me it's a sine curve. So we always have to do y equals. So I'm going to put the sign there, and then I can see that this height here is 2 and this minimum is negative 2. So that tells me the amplitude is 2. And then I'm looking at getting 1, 2, 3 complete sine curves. So that's my frequency from 0 to 2 pi x. Number 2, this one is starting at 1, so it's a cosine. The amplitude, it's starting at 2. So that happens to be my amplitude, so 2 cosine. I am seeing only half of a cosine curve. The rest of it I put in dotted lines. So that's going to be 1/2 x. Or you could say y equals 2 cosine x divided by 2, okay, or 0.5. Next one, it's starting at negative 1, so that is a cosine curve. And because it's starting at negative 1, it's going to be a reflection over the x-axis. This amplitude is 1, so it's not negative 2 or negative 3, it's negative 1 cosine. And then to find that period, that frequency, I need to look at the period. The formula is p equals 2 pi divided by b. Now, period means when you are seeing one complete curve finish. I am seeing one complete curve finish by 2 pi over 3. So this is the period, so I can substitute that in for p in my formula. So 2 pi over 3 equals 2 pi over b. And I think you can see then that b would be 3. So 2 pi over 3 is 120 degrees, by the way, if you convert that. the answer is 3x, but to make sense of this, I would get one curve in by 120, then there'd be another curve by 240, and then the third curve would be by 360. So that's why there's 3 for the frequency. And then the fourth example, it is starting at 0, so it's a sine curve. It's going up, so it's positive. The amplitude is 1. You don't have to write that. I'm the 1 there, I just am. And then I'm getting one complete curve by pi. Well, the frequency needs to be how many curves by 2 pi? So if I kept this going, it's symmetrical. It's not going to all of a sudden, like, you know, go faster or slower. It's going to go at the same rate. So I should finish another curve by 2 pi, which tells me I'm getting in 2 sine curves. Here's where the first one ends. The second one begins at pi and ends at 2 pi. All right, so that's how you do those. Next, we're going to graph these. Back we talked about one cycle. Do you remember what one cycle refers to? It refers to one complete curve. Now when you're graphing these, for y equals sine, that they have like some key points. The starting point, then it goes up to that amplitude, then it comes back down, goes down, and then it goes back to where it starts. So those 5 key points, I think my orientation is off. Okay, so let's try graphing that again. That was a bit messy. Okay, so we've got a key point here. We go up, we come back, we go down the same amount, and we come back. It's always going to be symmetrical like that. So the distance from here to here is the same as the distance. So if this is 2 pi, then 0 to pi is the same distance. And the distance up is always the same, and the distance down is always the same. So there are these 5 key points. For y equals cosine x, we have the same thing. Key points, except it starts up here, then it goes to the x-axis, then it goes down the same amount, back to the x-axis, and back up. There are, again, 5 key points that you want to put your, you want to kind of graph your cosine around. So this would be 1, -1, and again, this could be 2 pi, could be pi, but I'm just saying 2 pi. So those are 1 complete curves of the sine and cosine. So we're going to graph 1 cycle of each function. We should be in degree mode. And in y1, we're going to put negative cosine. The parentheses is going to come up, and we'll put 2x in there. So look at 1 complete cycle. So go to your window. So I have negative cos 2x. And I'll just hit zoom 6 for now. And I just need 1 complete cycle. So what did I do wrong? Okay, so it must not be going to zoom 7. That's my problem. I don't know why. Okay, so there we go. So you can see 1 complete cycle starts down at -1 and goes, and if you notice in your window, the x scale is by 90. So each little mark is 90 degrees. So it's finishing 1 complete curve by 180. So I'm going to graph from 0 to 180. So if I change this to go 0 to 180, and then I graph it there is one complete cycle. But you have to notice, you know, that that's one complete cycle. We're going 0 to 180 to get that in. So let me show you how to graph this then without having to use the table. So I have my x-min at 0. I have my x-max at 180 because that's when I saw one complete cycle. I left my x-scale at 90. You can put it at 30 if you want, and then you can use the table. The y-min should be at -4 and the y-max at 4. The amplitude was 1, not -1. The frequency is 2, and the period is pi, because it's 2 pi divided by 2. So we're going to graph one complete cycle from 0 to pi. So I'm going to go here to pi over 2, and then to pi. And I'll go up 1 and down -1. So I know that my basic cosine curve has a beginning point, and this one began down at -1 because it was reflected over the x-axis. And then it's going to go, it's going to have the same ending point, so I can go to pi and place that ending point. And then halfway between, it's going to be at its max point, which is going to be at 1. And then halfway between 0 and 90, it's going to be at its halfway point on the x-axis. And halfway between 90 and 180, it's going to be at its half point. And that is those are those key points that I need to graph. Now, you can check those out in the table. I'm going to have it start at 0, and you can have an increment by, say, 30. And if you look at those values, we should have those. 0 is at -1. 30 we can put at -0.5. 90 is at 1. 60, if you wanted to see what's going on at 45, do second trace, and then value. Oh, hold on a second. Second trace, value. And you can type in 45. At 45, we were at 0. Okay, so you should be able to see those key points. All right, the last one. Y equals 2 sine 1/2 x. So now I'm going to put in y1 equals 2 sine, you can do 0.5. I'm going to do x divided by 2 this time. And then I'm going to see when I get the one complete curve. So go back here, and let's clear this and change it to 2 sine x divided by 2. And if I go to zoom 6, I didn't mean to do that. I'm going to go to zoom 7 instead. Nope. Okay, there we go. I keep doing the zoom 6. I want zoom trig. All right, so you see, I want one complete cycle of sine, so that's a negative cycle. I think I really want the positive cycle. So this is going from 0 to basically 360. It's going from -360 to 360. So if I change that to 0, and I change this x max to 360, and I hit graph, you see I'm only going to see half of a sine curve. So I need to take that window and I need to double it, 360 times 2. So 360, you can even put in times 2, and it will say 720. And then when you graph that, now you will see one complete cycle, and that's what we need. So you can look, maybe go by 90s in the table. If you really want to look at the table, you can look at, get your points there. I'm going to use just my my skeleton points. So my x-min was 0, my x-max was 720, and my x-scale I kept at 90. This was at -4 and 4. My amplitude is 2, my frequency is 1/2, my period was 4 pi or 720, because that's how long it took me to get that one complete curve. So I'm going to go like this. So I'm going to start with pi over 2, pi, 3 pi over 2, and 2 pi. Now up top here, we need to keep this going. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3 to 4 pi. But how do I label the other ones? So up at the top here, this one is 1 pi over 2. This one really was 2 pi over 2. This was 3 pi over 2. Hopefully you see the pattern developing here. This is 4 pi over 2. So the next one would be 5 pi over 2. Which is 360 plus 90, which is 360, 450, right, in degrees. And so this one's going to be 6 pi over 2, which is really 3 pi, and that should make sense. Here's pi, then 2 pi, then 3 pi, and then the last one would be 7 pi over 2. And then 8 pi over 2, which simplifies to 4 pi. So that's how I would label those. And then I'm going to go up 1 and 2 and down -1 and down -2. And my sine curve basically has a beginning and an ending at the same spot. And then in the middle, halfway between, I'm at 2 pi. And then I went up. I did not reflect, so I'm going to go up to my height of 2. And then halfway between the 2 pi and the 4 pi, I'm going to be down to my minimum value of -2. So you see I can use those 5 skeleton points to get my one complete cycle. And that concludes the lesson. Sorry it was so long.